Okay, hi. So here is the next tutorial about how do we visualize our results. So in the last tutorial, what we did is we wrote these two for loops. Uh, for loop over test folds from 1 to the number of folds, which is 5 here. And we wrote this other for loop over these different data sets, either a scaled or unscaled version of the input data. And for each one, we're running just the one nearest neighbor's algorithm, very simple machine learning algorithm to compute predictions. And then we're storing the prediction accuracy here in this data table, this list of data tables. Finally, I combine it and we get this data table which tells us for every test fold for either the scaled or unscaled version of the data, what is the percent accuracy of that classifier in the binary classification problem. And so to visualize that, I'm going to recommend that we use the ggplot2 package. So again, here I'm going to put that inside of an if false because we don't want to execute this every time. But here I'm going to put install packages ggplot2. And what that means, again, install packages means download from the central R package repository a package, the most recent version of the package called ggplot2, and get install that on that copy on my local machine. So that's what it's doing right now. So you can do that to get the most recent version of that package. And then after that, we're going to attach that package using library. So library is a new function I haven't talked about in previous screencasts, but what it does is it takes all of the functions that are defined and exported in that package and it makes them available to you for use on the command line. So contrast that with what we were doing before with data table. Remember we did the install packages data table earlier, but then we were using data table using this double colon prefix, right? So before the colon is the package name, after the colon is the function name in that package. And so if we use this library syntax instead, we don't have to write this data table or, the package colon thing. So that's the reason why we use, we do that usually with, you can do that with any package. And in fact, with ggplot2, you can use ggplots, with the double colon syntax as well, but usually we use the library function instead just because it provides so many different functions, and so it's kind of tedious to just type ggplot2 colon every time. So here I'm using library ggplot2, and so now we get access to the ggplot function. The GG means the grammar of graphics, so it's a very specific way of making plots, but it's super convenient. And so what we can do is to visualize the results that we just computed in that data table above, we can use a geom point. And so in the definition of every ggplot, you have one or more geoms. For every geom, you have this AES definition, which means an aesthetic mapping. So in an aesthetic mapping, you're going to have a bunch of different arguments. On the left-hand side is going to be the visual properties. And then on the right-hand side of the equal sign are going to be your data variables. So for example, one of the visual properties that we might want to use is x. That's the x or the horizontal axis. And so in this data set, we have variables test fold, data name, and accuracy percent. So the accuracy percent, we can map that to the x-axis. To the y-axis, we might put the other variable, the data name, and we don't have to use that other variable, the test fold. We'll just see a dot for every different value. And so here we have to specify what data set we're using. And so that's data equals pred ac dt. And so what this means is here we're going to use a data set called pred ac dt. And so remember, this is this data set that we were just looking at that has these three columns. And so when we use this aesthetic mapping, it's going to, on the right hand side, it's again these data variables. So it's referring to these values that we see in the data table, right? So it means put these values on the x-axis, put these values on the y-axis. So let's see what that ggplot looks like. So the ggplot shows up in the plotting area over here, And so we can see in this plot of accuracy percent versus the data name, we can see clearly that the scaled one has higher accuracy scores than the unscaled. So this is, like I was saying earlier, usually with most machine learning models and data sets, they're going to perform better if you scale the data beforehand. So that's a really important pre-processing step. So thanks for listening, and I hope you learned a little bit about data visualization. So just to summarize, we are using the ggplot2 package. It provides this ggplot function. It provides the geonPoint function and the AES function, all this stuff. And what it does, you have to provide a mapping of visual properties to data variables, and you have to provide a data set for every one of these geoms. Then after that, the geoms will be rendered in a plot that can let you visualize, if one model is better than another. Here we see one is better than the other. And just a final note, if you use a question mark geom point, you can see the doc page for the geom point function. And you can see in particular, the two arguments that we were using were the mapping and the data arguments. But the more important thing here is, here there's always an aesthetic section for these geom functions. So it's important to review this. So geom point understands the following aesthetics. So X and Y are required. Those are the ones that we were using. But also it understands all of these other ones like alpha, color, fill group, shape, size, and stroke. So you can learn more about setting these aesthetics in vignette ggplot2 specs. So you can type that at the command line, and you can it'll pop up a web browser help window that explains all of these different aesthetics that you can use. For example, you know, going back, you can see that, one of the things they mentioned was color, and if you wanted to use that, for example, to represent the different test folds, we could add that as another uh, element of the aesthetic mapping. So it's not super informative to look at that. So usually I wouldn't recommend that, but just an idea. Again, you put the visual properties that are mentioned on the geom man page over on the left side, and you put the data variables over there on the right side. And the way that you can tell which of these visual properties to use, you can just go look at the man page. Also, and for more generally, when you want to make a plot, you can look at all the different geoms that you have here. Geom AB line, area bar, all of this stuff. You can also Google ggplot2. There's a bunch of really useful examples online about what all of these look like. And you can also look at the examples in R. So, I mean, for example, if you want to use the geom AB line, what is that? So you can look at example, and then it'll give you some example code to run, and it'll show you some various examples of using. Here it uses a geom V line to draw a vertical line. Here it shows you the code to use a geom H line to draw a horizontal line. Here it draws AB line, which doesn't really make sense given these data. I don't know if that's supposed to be a fit or what. Here, yeah, that makes more sense as a linear fit, but you get the idea. So all of these things, you can use the internal R help facility to learn more about how to use these different functions. Thanks for listening, and see you next time.